Now, it's really easy to eliminate z because I have just the ones and the negative ones, right? I did that for that illustration. But for this one, I'm going to start out by doing 1/3 of this row. One-third times the first row gives me 1, negative 5/3, 1/3, negative 5/3. Then we're going to have a second row. And the third row. Okay? Well then, I'm going to do this. Okay, my first row is going to say what it is. 1, negative 5/3, 1/3, negative 5/3. Then I'm going to multiply whatever's in this row by -1 and add it to the second row. Or by negative 5, I'm sorry. And add it to the second row. Well, negative 5 times 1 is negative 5. Added to 5 gives me 0. That's convenient. Okay. Then negative 5 times negative 5/3 is negative 25/3, which I add to 7. 7 being 21/3. That should give me negative 4/3. Now, I'm almost inevitably going to screw something up here, but you see the process. Okay? And then negative 5 times 1, and I did screw it up because negative 5 times negative 5/3 is 25/3. You see how easy it is to make errors with signs, although I find it easy to make all kinds of errors. Like I say, I'm approaching my 30th birthday.
Okay.
You know, you start losing it. Okay. Yeah, the working memory thing. Okay, 46/3. Okay, because I'm getting 25/3, and it's actually 35/3, not 25/3. No, it's 21/3. Okay, it's 46/3. Okay. Then negative 5/3 here to negative 3/3 gives me negative 8/3. And 25/3 and 4, which is 12/3, is 37/3. Okay? Then down here, I'm going to add negative 2 times the first row, and that's going to get rid of this 2. And then I'm going to get rid of, well, I'm not going to get rid of, I'm going to do negative 2 times the first row is 10/3. Added to negative 12/3 gives me negative 2/3. Okay? Then here, negative 2/3 added to 1 gives me 1/3. And then negative 10/3 added to 8, which is 24/3, gives me 14/3. Okay? Now, what I ultimately want is I want equations that look like this. Now, what would this equation look like in matrix form? It would look like 1, 0, 0, negative 27 over 10. 0, 1, 0, 1 over 3 over 10, 0, 0, 1, 357 over 10. Okay? If we've got a 1, 0, 0, 0, 1, 0, 0, 0, 1 here, we're going to have our solutions here. Our x, y, and z values will be right here. Okay? So, you see how I'm making progress to that. Okay, I get zeros here. Okay, then probably, well, I can easily get the next step. Okay? And the next step is going to be to get a 0 here. I'm sorry, to get a 1 here. And then we can use that to get a 0 here and a 0 here. Now what I don't want is I don't want to be multiplying this equation by 3/46. I'd much rather have this equation here. Well, the order of the equations makes no difference at all. The equations are what they are, so I can flip rows. So I have 1, negative 5/3, 1/3, negative 5/3. I'll have 0, negative 2/3, negative 8/3, 37/3. What is the matter with me? I know what's the matter with me. Inattentiveness and lack of working memory. Failure to keep thinking. I'm putting the third row there. The third row has a 1/3, and a 14/3. I almost did it again. It's 37/3. Okay? And now if I take 3/2 of these numbers, things are going to end up much nicer. Okay? So actually I can do one more step here. It's getting a little sloppy, but I'm just going to do negative 3/2 of each of these numbers, which make all the denominators 1, right? And I'm just going to have the numerator. So this is negative 3/2 times row 2. Then I'll add 5/3 of this row to this one. Negative 46/3 times this row to this one. And I'll have zeros here and here. Okay? So I got to get from here to here. See how to do it? Okay, so that's one thing guys could do for homework. See if it agrees with this, which it probably won't. Not sure how we're going to get denominators of 5 out of this, but maybe. Haven't really looked closely at it. If I did, I think I'd see what I want to see, but maybe. Okay. Now, you understand that everything I do here, I'm really just doing to the whole equation. And all I'm doing is what? Adding 2 equations, or multiples of the 2 equations. Multiple of this plus a multiple of this. And usually the multiple of one of them is just one, I just, you know, because of the way I'm doing this, okay? I can switch equations, okay? Or I can multiply an equation by a number.
So it's basically just a simplified format of, like
I'm sorry?
it's like a simplified format, it's just a different way of looking at it.
Yeah, yeah, and this is how we do, it's called Gauss-Jordan. Yeah, we reduce to the Gauss-Jordan form, Gauss-Jordan reduction. Another alternative, we could have reduced it to just a triangular form where you could still have numbers here, here, and here. Because the last row tells you what z is, and then you plug it in here and find y, and you can bad substitute and find x, right? Okay? So that's Gaussian reduction. Gauss-Jordan reduction brings you down to where you just have the ones. And it's kind of a, in many cases, when you're just trying to solve a system of equations, it's really a matter of taste. Okay? If you've got an algorithm in your computer that does the upper triangular form, then you might as well just let it go 2 more steps and get the full solution instead of having to back substitute. But then you get into efficiency of algorithms, stuff like that, and maybe it's more efficient to do something different. Okay? So